Hello everyone, this is Swagatam here, and today we'll be talking about modeling. So hackathon competition. So people who are new to this, so I'll be telling you how you can go do it. So after doing this, you'll be able to do end-to-end hackathon, and you can score very really good score from here. So there are plenty of things that is there, but yeah, we will try to show it in a easiest way so that it will be easy, like it won't be a problem for you. You can also start doing your own thing. So here you go. So basically, whenever you will be participating in a hackathon, there will be three types of data. One will be trained data, the other one will be the test data. So and the other one will be the submission file. So basically, what is there in the trained data? You have the feature what you need to predict, and you have the other features also. But in case of test data, basically you will be getting the apart from the target variable or the target features, you will be getting the rest of the features. So as you can see here, I have loaded under df the train data, under df underscore test. I have loaded the test data, and if you am looking at the shape of the data, you can see this is the row number and this is the column number. So here column number is 22, and here in the test data the column number is 21, and row number you can see 762 1888. So here basically we need to build the model, and for building the model, what are the things that we need to consider? So basically you can see, first we'll be talking about like how this data looks like. So you can see here click rate is there and the other features are there. So during competition they will also tell you what are the things that you need to predict. So after that we'll be looking at like what is there any missing value present in the data or not. So if we'll be doing the df.info, that is what will be giving the overall data info. You can see all the features that is present there. Total 21 features are there, and there is no null value that is there. And this is the type of the data that is also present there, int object. So this is how the things are there. So then if we'll be going down, and then you can see what I have tried to see. I have tried to see what are the unique number of category that is present there in these features. Now how will it help me out? It will help me out to understand which all are categorical variable and which all are numerical variable. You can, what you can do other apart from that, you can also have a look at the data. You can see here body length itself, it's showing there, that's a numerical features. Whenever it's come to day of the week, as we know there are 7 days in a week, so that we can consider as a categorical features. So here why we need to understand all this. So as we know the system doesn't understand categorical and numerical thing, what it can understand, it can understand the number. So it's very important for us to give a or make us our model understand a significant representation of any features by a number. Now how better you can do that, and that is what will be that is what will be helping you basically to understand the model, and it will be able to predict it properly. So if we'll be going down, okay, so let me show you how this thing little bit code. So you can see here what we are doing for column in df.columns. So basically df.columns will be giving all the features name. So I am finding out what will be the unique value for each features, and this is the features. I'm just storing them in under dictionary. So this is and then what I've seen, I've just shown the dictionary. Then from here you can see what is the number of categories, okay, present there. So you can see if body length is 1568, it was numerical, we have seen that too. But there is certain categories, okay, what you can see here like category itself, okay, there is 16 numbers are there. Okay, so suppose product, there is 43 products are there. So what is usually what we do in case of categorical variable, we do one hot encoding. So in case of one hot encoding, it's very important our model will be able to understand data very easily if we can, instead of like increasing number of features, if we'll like if we try to reduce the number of features, then it will be better for us. So in that case what will be there, so suppose there are 43 categories are there. So here what we will be doing, we will be doing the target encoding. So what is this target encoding basically? So depends on the distribution of the click rate. So suppose I am categorize them, like basically segregate all the click rates on the basis of each each category. So for each category, if the distribution is similar, then we can cluster them under same thing. So suppose they are under product A and product D, both of them have the similar distribution of the click rate, then we will be categorize or cluster them in the same under same uh, tag. So that will be the whole thing. So once I'll be showing you, you will be able to understand more. So it's a very interesting thing, and I think it's a very important thing that we need to do. And feature engineering is the most important part in any hackathon. That is what will be making you rank. How good you are representing the numbers or the features, that is what will be giving you good result. So after that, you can see here, this is what I have tried to see. Like you can see a campaign ID. So yeah, this is the distribution that I have tried to see. So what we have done, after looking at the number of different categories and looking at the data, we have segregated the features. I have basically segregated the features in different things. So you can see here there is one bin column is there. So that means it's a binary, basically either 1 or 0. That is the kind of response that we have seen in case of this category. There is one category clusters. So as I have spoken about, so there are like certain like features which who all have like more than 20 or more than 50 number of category. So we have reduced them into 4 or 5 numbers of category. So that you can take your call, depends on like which one is working good. You can choose that one, that feature. So there is no hard and fast rule that you need to do it after this or after any particular number of category or less, like more than 10 category or less than 10 category, that there is nothing like that. So you can choose it by yourself. Then what we have done, so basically here we have deleted few columns. So each price and each timer, we deleted this two here. And as this, I found that that is not significant. It's up to you completely what you need to decide. So then what I have done, why I have tried to see all the numerical features distribution. So you can see this is how the distribution is showing. So SNS is the abbreviation, it's an alias of Seaborn. So sns.distplot can give a very good distribution curve. So that is what I have used it here. So if you will be going down, so you can see um, what I have done here. Basically, this is what I was talking about. This is called target encoding. So here you can see here, so basically there is one under there is one like cat under under data frame. So we are just describing, you can see here df.group by call click rate describes. So here for each features category wise, we have shown, we have seen the distribution, and then what we have done, we have tagged them. So if you'll be going through this code, you will be able to understand the whole thing. So here basically we have produced the dictionary. So if you'll be looking at this data, so here what we have done, so you can see here feature cluster name, these are the dictionary that you have defined. Then what we have done for you can see here, as I told, this is what the distribution for each category of each features we are showing, and then we are clustering them, and here we are storing them under the data frame, you can see here. So after that, this is how it will look. So suppose there is one category, in that category there is one feature name category, under that there is 0 1 2 3 4. These are the various cat like what I would say, under that features various categories are there. So you can see this is the distribution count, mean, standard deviation, mean, 25%, 50%, 75% max, that you can see here. So if I am cluster them, so this is what I have shown it here. So you can see here category clusters. So what you can see here, we have basically segregated them in different cluster, and we can have a look at this. So on the basis of this also, you can choose the number of clusters that you need to choose. So here with respect to click rate mean, we have categorized the features. So this will help us to predict the things very accurately or better in a better way. So after that, if we are going down, so these are the all things, all codes will be there. You can go through all that and you let me know in case if you are not able to understand anything in under comments. So you can see here then what we have done. Excuse me. Yeah, so you can see here I basically segregated the train data and the test data. So and also here you can see why under y train, this is the thing that we need to predict click rate. So under df underscore updated, so I'm just putting this click rate, and here the other features are there. So basically under the model we will be passing x and y, both of them. That will be what it will be trained by the model. I'll be showing the same to you. So this is how the data is looking right now. So you can see here what I have seen. I have tried to see the skewness of each and every column. You can see here that's what it's mentioned. So for each and every column in the X train, I am looking at the skewness. Then what we are doing, I am performing np log. So basically I am just doing the log normalization. So it will be, so what will happen, so if any features is skewed, then in that case it will, after doing the log transformation, it will be more towards normal distribution, and whenever the numerical features are in normal distribution, it will help your model to predict in a better way. So that's how the thing. So in certain cases, though I haven't done it in this case, in case of regression model, when we need to do the we can do the log transformation for the output also, or the target variable also, target features also. Later on we can again we can convert them by using np.exp. So after prediction value, so that will also give us a very good results. As you can see in my previous video, that is what I have done. So here what I have done, you can see these are the like object calls. That means these are the categorical features that is present there. So after that, here what we have done, here we have done one hot encoding. So you can see here one hot encoder that we have loaded from the sklearn.preprocessing. I have imported one hot encoder, then I have defined the functions. So after that, what we have done on the train data's various features, what I have taken object calls that we have defined, that is the categorical columns. On the categorical columns, what I am doing, one hot encoding, and I am storing them under the as a data frame under OH columns. Then what we are doing, we are giving the index number to the data frame, then we are giving the column names. So you can see here OH underscore encoder dot get underscore feature underscore names whenever we are giving the object columns. So this is what will be giving the name of the features for the data frame that we have defined under OH column calls. So then what we are doing, basically we are deleting all the columns that is present here, because we have converted them into one hot encoding. Then what we are doing, we are just doing the concatenation with the original data. And this is what the after transformation of the one hot encoding, this will be the extend. The similar thing has been done in case of xtest. Only the difference what is there, here we have used fit underscore transform, and here we have done transform. So here data leakages are happening, but but we need to do this one because we need to work on a bigger problem. We need to make a generalized model, so for that purpose we need to do that. Then what we have done, we have done scaling. So about scaling, you can do Google, you will be able to learn about it. So there are various scaling are there. One is min max scaling, the other one is standard scaler, then robust scaler. You can go to Google and you can have a look at this. I will be in you can learn about it in YouTube also. There are so many contents are available for various scalar thing. So what I am doing, similar thing we have on the train data, I have used this scaling part and I have transformed them and I'm storing them. So you can see this is a very easy way how you can write the codes. So basically as I have explained earlier also, here for loop we have used. So for every column in the extent. So what we are doing, we are doing the min max, we are doing the min max scalar transformation. So here scalar is the function that is defined min max scalar. Then I am doing scalar dot fit underscore transform on the train data and scalar dot transform on the test data. So after doing that, if we'll be coming down, so you can see here there is one more very important thing that is called feature selection. So what we are doing here, our main work is to predict the predict y. So how are we doing that? So what we need to see, like what is the significance of the features. In certain cases number of features will be very high, so in that cases what happens, but there is no relationship between the target variable and that features. So if there is no relationship, then we need to drop that feature so that our model will be working very fine. So you can see here we have related all the low correlated features here, who all have, like, there is no relationship here, 0. So there are, you can see a number of low correlated features dropped, 7. So there are 7 features which all are dropped here. So then what I have done, I have loaded cat boost. How you can load it, pip install cat boost. Cat boost is a very good I found it, it's very helpful for like model what we can use, or the module what we can use for categorical features predictions and regression as well. So classification or regression, for both of them, it's working very good. Then what we have done here, you can see here we have used grid search CV. So basically grid search CV, that also you can get it from sklearn. So if we'll be looking it here, okay, yeah, sklearn dot model underscore selection import grid search CV. So grid search CV, we use this for hyper tuning. So I'll be telling more about the same on the later part. So after that, you can see here the model, here the parameters that we need to pass. So I'll be telling about the same later. You can see here cross validation. So here what is the things are there, let me talk more about that. So here basically it will try to fit various it on the various parameters. It will be checking which parameter for for one particular model, which parameter is giving me better result. That is what the main purpose of hypertuning. Okay, so so if I'm doing cross validation 5, so there will be, suppose there is 100, hypothetically I'm just taking, there is 100 columns that is present there. If I'm doing cross validation of 5, then it will be dividing segregating the 5 equal parts. So suppose if I'm 100 rows, if I'm dividing in 5 equal parts, then the last part, if if I'm taking suppose from 80 to 100, and the rest of them will be from 1 to say 79 or 80 rather. So 1 to 80 will be the train data, and rest 20 numbers will be the test data. So similarly, for each and every data, this training will be happening, and it will be checking the best features. So this is what will be helping you. Basically the purpose of this cross validation is to avoid the overfitting. So basically our main purpose is to make a generalized model where low bias and uh, it should be low bias and low variance kind of model. So you can see here that is how we have trained it. So I'll be giving this code, you can go through it. In case of any problem, just let me know. Here you can see I have just shown the result, cross validation results that you can see here. So after that, here also you can get best estimators. So here if you will be coming little bit down, that is what I was talking about. So here basically you can see under model we have defined various models. So gradient boosting, Bayesian ridge, LGBM regressor, cat boost regressor, everything we have function we have defined here. We loaded them from the from a particular module. Then what we are doing, we are passing the parameters here. So you can see here ridge params. So what is there, reach params is there. So here value of alpha we are passing through. You can give various values, and you can do your you can by using hyper tuning like grid search CV, you can check like which value of alpha will be giving you better result, or what will be the number of length will be giving me number of lives, sorry, will be giving you better result, what will be the number of estimator is giving me better result, that you can do it there. And after that, what you can do, you can define the function, and I have used this stars because here we are passing the dictionary under this function, that's why I have used double star. So what you can see here in the next, so I have fitted for each and every model under this model dot item. So this is the models, that is a dictionary which is storing all the model. So I am fitting all the model on with the X train and Y train. Then what we are doing, we are checking, we are storing the results of them, predictions. And this is how the after print, if I'm printing it here, for you can see here, this will be the results for GBR, BR, Ridge, LGBM, cat boost. So you can see here which model is giving me good performance. So you can see here cat boost is giving me better performance than GBR. So what you can do here, you can then give the weightage to these models for the predictions. So this is the weight that is given here. I am not going in detail, very depth, you can understand. So what is the things are happening, so whichever model is giving better result, I am giving them more weightage. So cat boost is giving me better result, so I am giving more weightage to that. Then I am checking the R score. The similar thing is done on the test data, and we are storing them under Y parade. Then what we are doing, we are storing them under this submission file, and this is the name of the file and the path where we are saving. We are running that, and this data will be saved there. And after doing that, after you will be getting the uh, CSV file, and you can upload it into the checker. So that's all. In case any query about my uh, presentation, let me know. Please subscribe, that will be like that's like Thanksgiving thing for me, and I'll be also happy and motivated to make more videos on these projects. Thank you.